Hi, welcome back. So we are on this chapter 8 on ray optics and optical instruments. So in that, we just discussed about what is the meaning of ray optics and when do we consider rays, and how actually the laws of reflection works everywhere. And we also discussed about if you given a spherical mirror, which is a concave mirror, we showed that F is equal to R by 2. Okay, and we will discuss also some sign conventions. We also discussed what are the kinds of rays you need to take to form the image and all that. So now we are going to do a derivation of mirror equation. So mirror equation we know from our earlier classes that in 9th standard or 10th standard you would have probably done mirror equation where 1 by f is equal to 1 by v plus 1 by u, where f was focal length, v and u are image distance and object distance respectively. So now how to do that? We will take one example. In the sense image formation by keeping the object at one particular point, and we will do this, but the same derivation can be applicable for every kind of scenarios of every kind of mirror. Okay, so like either concave or convex or wherever you keep the object, the rules are same. Okay, now I am going to basically write the concave mirror. It's supposed to be a thin mirror, but I have just written a easy to. So this is my principal axis. So let's make it a little bit more straighter. And this point is P. Okay. So we're going to take this point, let us say, as C, and we'll take the point here as F, and we can keep the object somewhere here beyond C. This is an object which is, we call it as AB. Generally that's how we call the object. Okay, we will use very consistent naming terminologies basically to make sure that you don't get confused. Whenever we talk about an object we say AB, whenever we talk about an image we say A dash B dash. Okay, and C is always center of curvature, F is always focal point. Okay, this point is focal point, this length is focal length. So we take one ray which is parallel to the axis, hence it goes via F. It's one ray, and we call this point as M. Now I am going to basically say that they are all paraxial rays. Hence, this MP and this line, let us say, these two are according to me same. Okay, in the sense that when you go very near to this, this will become as good as a perpendicular line. So I will call this itself as a perpendicular straight line, and it's a triangle. Okay, I will just assume that to be a triangle. Okay, so that is one assumption. And then one more line I will take it here, a second one. Which actually again kind of reflects. So it is going to the P, goes to P. Goes to P and then reflects. Okay, like this. So these 2 points actually meet here. So what have I done? I have actually taken 2 rays starting from B, and both of those rays will are meeting at this point, and that I will call it as B dash. Even if I take many more rays from B, and they all will meet at B dash. Okay. So now I will just draw here one ray from A going to this and coming back. So I will just take A comes here. Okay, these are the image formation that you have kind of done before. I will not spend more time on that. A dash. So I am now going to consider basically some triangles, okay, similar triangles and work with it. For example, I will consider now this triangle, okay. So I'll just mark it like this triangle, and this triangle, this whole triangle. These two triangles I will consider. See, my aim is very simple. My aim is to basically find out the relationship between image distance, that is from here to here, object distance from here to here, and focal point, focal length f. So I try to consider some different triangles where those are involved, and then there are similar triangles. I'll take the ratios and work some algebra and get the answer. That is the whole thing. Okay, these two are the two triangles I will take, and I will also take two more triangles. Okay, what are those triangles? One is this triangle from here to here. Okay, this triangle, we'll call it as ABP triangle. Okay, and one more triangle I'm going to consider, which is A dash B dash and P. See this triangle. So I'm going to basically mark it like this so that it's somewhat easier for you to look at those triangles. Look at this triangle and this triangle. I hope you can actually get a better view of triangles here. Now this triangle and this triangle, then this triangle and this triangle, I'm going to make them as similar triangles. Okay, let's consider them. Okay, what I'm doing here you can see. First, consider triangle. This is A dash, B dash and F. Okay, and this side it is MPF. Okay, MPF. As I told you, I'm taking MP as a line, straight line, okay, because of my coaxial, paraxial. So these two triangles I take, and I claim that they are similar. Why are they similar? Because this angle is 90 and this angle is 90. Okay, and this are vertically opposite angles. Two angles are equal means third angle also are equal. So all three angles are equal means similar. Okay, so by angle equal property, okay, angles are equal. So I'll now write the ratios. What ratios I will write? A dash B dash divided by this height, that is PM, corresponding sides ratios are equal in a similar triangles. Okay. A dash B dash is a corresponding side to PM, and similarly A dash F is a corresponding side to FP. A dash F and FP or PF. A dash F and PF. So this is one equation. Now, equation number 1. So let me also make small change in this equation. So now in this equation we know that PM is actually equal to AB. This height and this height are same because these two lines are parallel. So we can say that this is nothing but A dash B dash by AB is equal to A dash F by PF. This is my equation 1. Now we consider the other two triangles. Consider triangle ABP and triangle A dash B dash P. So one triangle involving the object, another triangle involving the image. Okay. So when you do that, you can see here that are they similar? They are similar. Why are they similar? You can see that in those triangles, these two are equal angles. Why they are equal? Because angle of incidence is equal to angle of reflection. They are similar. And these two are right angle triangles. Right angles. So two angles equal, third angle equal, three triangles are equal, similar. Angles equal. Okay. So A dash B dash by AB corresponding sides. A dash B dash by AB corresponding sides. So I will take this corresponding side as PA dash. Okay. PA dash by PA. Okay. So the corresponding side. So this is 2. So LHS of 2 are equal. So RHS have to be equal. So from 1 and 2, A dash F by PF is equal to PA dash by PA. So I am going to write this A dash F as PA dash minus PF. PA dash minus PF. PA dash minus PF divided by PF is equal to PA dash by PA. Okay. Now I will apply sign conventions and write down basically what are these values of image distance, object distance, etc. Okay. So PA is equal to, okay, object distance U. However, we are going to measure from the pole. Okay, if you measure from the pole and come towards A, our rule says all distances have to be measured from the pole. So we measure from the pole and come towards A. So while doing so, you are traveling. The second rule says if you are traveling, when you are measuring, when you travel in the opposite direction of the incident ray, take it negative. Okay. So it is negative. PA is negative U. Okay. And PA dash, what is PA dash? Is image distance, again opposite direction, so negative V. Okay. And PF, again opposite, negative F. So let's substitute that. So PA dash is basically negative U, negative V, sorry, negative V. PF is negative F minus of minus F divided by minus F is equal to PA dash again is minus V divided by minus U. So this actually implies minus of minus plus F. So F minus V by minus F, which is minus of V minus F. Again it will become V minus F divided by F is equal to V by U. So this we will again write it as, this implies V by F minus F by F, which is 1, is equal to V by U. So what do you do with that? You take the one the other side. Okay. So I am going to continue it where, let's say I will do it here. It's a small one. Okay, I will do it here. Okay. V by F is equal to P by U plus 1, or I will basically divide everywhere by V. 1 by F is equal to 1 by U plus 1 by V. This is the formula, that mirror equation that we derived. Okay. So you understood now this very simple derivation. So the derivation requires you to draw, remember what you need to do for the derivation. You draw two lines. It can be derived in many different ways. Okay, this is one of the simplest ways. So what you do, you just draw two lines from here. You always use this. You can actually try proving it by keeping the object anywhere else, and then even imaginary image becoming virtual images. All sorts of things you can try. Okay, but to do the exam, remember this. Keep it just after C, so that you can get an image between C and F. Whenever an object is beyond C, image will be between C and F, and image is diminished, inverted, all that we know. Okay. So with that in mind, if you draw this, two lines you draw, two rays, one ray going parallel, another ray going directly to P. Okay. So they will join here. After that you have two sets of similar triangles, one involving just the image, one triangle here and the other triangle there. Okay, that second one is actually not even a triangle, but we call it a triangle approximately. Okay, and they are similar because of the angle rule. Then you take A dash by this height. This is same as AB. So A dash by AB is what you want to find out. A dash by AB. That is what you finally want to find out, and you get this. And when you take the other two triangles, one involving the object, other involving the image, again you get A dash by AB. Okay. So you equate the right hand side, and only the crux is A dash F, you have to write it as this whole length minus this length, because A dash F is nothing, that length we don't know. Okay, we know only object distance, image distance, and focal length. So this is image distance minus focal length. So that kind of a thing you write, and then you substitute properly this one. This is very important. Even when you are using it as in a convex mirror, or in other places, this may come differently. Okay, if you try to use that, okay, in the derivation. So derivation is slightly different, but will give the same result. So then you simplify it and you get the answer. So this is the derivation for the mirror equation. Okay. Now having derived that mirror equation, that again you have to understand that this is an example. This is true only if this is paraxial, in the sense that this is basically same as this. It's not too different. So let's erase this and let's do some problems. And before doing the problem, one last thing that we will do here. Okay, we will also write about what is the magnification. What is the magnification? Okay, so I'll erase this much part alone. Okay, and write down what is the magnification. Okay, so magnification is what? Magnification for us is A dash this height divided by this height. As simple as that. Magnification is, so let me do it here, M is equal to H dash by H. This is H dash, this is H. That means image height divided by object height. In this case, image height is smaller, so magnification will be less than 1. So in other cases, there may be magnification bigger than 1 also. So H dash by H, okay, which is nothing but A dash B dash by AB. Okay, so you can substitute here the A dash B dash and AB. Basically, they are in the form of U, and so we know that A dash B dash by AB. Okay, look at this equation. A dash B dash by AB is PA dash by PA. So we can write it as A dash from 2. We can write it as A dash B dash by AB is equal to PA dash by PA. So now you substitute basically with respect to the UV values. So and see what will come. Okay. So this is minus h a dash b dash by ab is minus h by h dash by h. One of them is negative, the other one is positive, is equal to, okay, this is again pa dash is minus v by minus u. So that means basically this implies, sorry, I'll have to basically do the array somewhere, let it here itself. So m is equal to nothing but, if you cancel these two, then you will get h dash by h is equal to minus v by u. M is same as minus h dash by h. This is minus h dash by, so you take the other side, minus v by u. So m is equal to minus v by u is the equation for the magnification. So given image distance and object distance, one can find out the magnification. So only these two things you need to remember, this formula and this formula, for solving the questions. However, this whole proof, if you remember, it's easy to solve some complex questions. Okay, so let's just solve some problems. So take down the question. Start with a simple question. An object is placed at 10 centimeters. An object is placed at 10 centimeters in front of the concave mirror. An object is placed at 10 centimeters in front of the concave mirror. So which is the meaning is basically u is equal to 10 centimeters concave mirror of radius of curvature 15 centimeters. R is equal to 15 centimeters. Find the position, nature and magnification of the image. Okay. So position, nature and magnification. So we will calculate first of all. Okay. Now focal length. So that's is nothing but r by 2, which is 7.5. And focal length, when you keep an image object and to in front of the mirror, the ray will be going from object to the mirror, whereas you have to measure from the mirror pole to the focal length. So focal length is actually negative. So this is minus 7.5, and we know object distance also is measured negative, minus 10. Okay. So let us write down 1 by f is equal to 1 by v plus 1 by u, which means we want to find out what image distance. So 1 by v is equal to 1 by f minus 1 by u, which is 1 by f is minus 7.5 minus u is minus 10. So this means 1 by 10 minus 1 by 7.5. How much is this? Let's calculate this. So this is nothing but 7.5 minus 10 divided by 725. This is basically 1 by v. So v is equal to 7.75 divided by 2.5, negative. That would be equal to. So if you calculate that value, you will get it as So 2.5 into 2 is 5, 5 into 25 is basically 5 into 5 ones are so 10 basically. So that this comes to basically 30 centimeters. So if you divide by 75 by 2.5, you get 30 centimeters. That means that you got a negative 30 centimeters, which means it will actually, if you keep a mirror like this, and if you put, look at this, f is 7.5. So this is f, 7.5, and 15 is r. So what you have here, u is minus 10. So that means u is somewhere here. So you are keeping object somewhere here. So this is 10. So the image you got as minus 30. That means somewhere back side here, here, from here to 30, inverted. Yeah. While it will be inverted, you know, you can calculate if it is between r and f, it will come beyond beyond c. This is c. So if you look at magnification, so you also have to find out the magnification. Magnification is equal to minus v by u, which is minus of minus 30 by u is minus 10, which is nothing but minus 3. So what is the meaning of magnification minus 3? That means it's 3 times, and minus means inverted. So object image is 3 times that of the object height, and minus means inverted. So it is inverted from the what is given in the object. So inverted. So this is how you can calculate using the formula. So you can actually try a couple of examples and substituting properly, get some practice on that. So another question. This is mostly a conceptual question. Let us see whether you will be able to do it. Okay. Suppose that the lower half of the concave mirror's reflecting surface is covered with the opaque, non-reflective material. Okay. What effect will this have on the image of an object placed in front of the mirror? In the sense that you have your mirror, let's say I am putting a front view of the mirror. Okay. This is the mirror like this. So on the mirror bottom half, cover with a paper. So if you write it like this, then that means that this much you have covered with a paper. So when you have covered that with the paper, then what would the image look like? So the answer is that you may think that if the object will basically only half the object will come, and it is completely wrong actually. The whole object comes as an image. Image will be similar to exactly like object only, no half of the object or anything. Okay. However, the intensity of the image will be less, because the amount of light that comes and joins. See, you look at whenever you talk about many different ways coming and rays and coming and joining at the same point to form the image. Out of that number of rays, generally we rate 2 rays, but I say there are millions of rays that come and join there. Out of that, half of them will not be there. Okay, if half of them will not be there, that point will be less brighter. That is all. So all points will be there; they are just less brighter. Okay, that is how the answer to this is. Now, there is another question. Okay, so now let us say, okay, I have a concave lens mirror, sorry, and on the concave mirror, let us say somewhere here is my f and here is my r, like this. So I am keeping on this. Okay, let's say my remote, okay, or a telephone or something like that, like this. So I am going to keep it like this. So okay, what will be the image? So let's just make an image and see how it looks like. Okay, I will take now this part and this part, okay, as two lines, and see those two lines, where do they appear in the image? From there I can find out. Okay, this line, let us say, when you are, this not R, I'll write it as C. Okay, the distance is R. So this point, if you look at it, on C, if you keep an object, the image will also be on C, inverted. So this line AB, I will say, and CD if you have. So AB, call it as the C, call this one as DE. So this AB will come here, A dash B dash, exactly same size, A dash B dash, and DE we will calculate where it will come. Okay, so DE, if I draw like this and like this, it will come somewhere here. This is the point of D. E. It will come like this. So dash. That means this side it is it is as is size. This one is enlarged. So if you take at any point in the middle, it will be approximately like that. Okay. So you actually get a picture something like this. So it's a distorted picture. So when you have it here and have it here, see, look at the picture is, the image is now distorted. So you have to learn this and how this image formation happens, because this side it is as is and this side it is expanded. So you have kept the, if you keep the object like this, it will not get distorted. If you keep it like this, then like this, or anyway in parallel to the axis, it will definitely get distorted like this. So depending, because at every point magnification will be different, that is why. So this is one example. Let's take another example. Suppose, so this is the example. Suppose while sitting in a parked car, okay, you notice a jogger approaching towards you in the side view mirror of R is equal to 2 meter. Okay, I have a side view mirror where R is equal to 2 meter. It's actually a convex mirror, so you will be seeing a virtual image. Okay. But our formula will still remain same. If the jogger is running at a speed of 5 meter per second, so jogger is running at a speed of 5 meter per second. So what is the, I will say it is U dash. U actually is object distance. U dash is object speed or velocity. So like that I am going to name. Okay. U dash is object speed, velocity coming towards us. Okay. So how fast the image of the jogger appear to move when the jogger is A 39 meters, B 29 meters, C 19 meters and D 9 meters away. So 4 different scenarios. A is when U is equal to 39 meters. When second one, U is equal to 29 meters. Third one, U is equal to 19 meters. Lastly 9 meters. So when all these scenarios I want to find out what is the velocity of the image v dash is equal to what. See, look at this. In this question, we are actually not calculating just the image distance. We are calculating the image velocity when compared to object velocity. How do we do that? So, we will do it using some basic methods first. Okay. So, we know this formula is true. 1 by v plus 1 by u. This formula is true. Okay. So, let us just write down the value of, this is a convex mirror. Okay. So, convex mirror, how does it form the image? We will see. The convex mirror. Car mirror is a convex mirror. So, you have a certain so when the object is when object is somewhere here, the light actually goes reflects like this. So, this is the incident ray and this is the focus. It would be, so that is, if you, the way it is reflected, if you actually subtend it backwards, project it backwards, it will go through F in a convex mirror. Yeah. And then one more we can take it like this, it will go with the same angle like this. And if you actually project these two backward like this, the image forms here. You can see that the image is smaller. Okay. So, if this is AB, this is A dash B dash, and it is erect and virtual. So, if you see here, the object distance u is positive, sorry, is negative. Why is it negative? Because you have to measure the object distance opposite to the incident ray. Incident ray coming here, you have to measure the opposite distance in the opposite direction. And V is positive because you have to measure the distance to the image from left to right, and the ray also moving from left to right. So, that is the same direction. So, positive. And focal length, you can see, we have to measure from left to right. Focal length is this side. So, is positive like that. Okay. So, those are the three important things that we know. Now, we will substitute anyway. 1 by f is equal to f. Have we been given f? We have given 2 meters. F is equal to 1 meter. Okay. We have been given f, and we are also given u. First one, u is equal to 39 meters. We will take u is equal to 39 meters. So, 1 by f, that is 1 by 1 is equal to 1 by v plus 1 by 39 minus 39. So, this means basically 1 is equal to 1 by v minus 1 by 39, or I will write it as 1 by v is equal to 1 plus 1 by 39. So, 1 plus 1 by 39 is nothing but 39 plus 1 is 40 by 39. So, v is equal to 39 by 40 centimeters or meters. Okay. So, what is the 39 here? Is 39 a meter or a centimeter? Meter. Okay. So, everything is in meters. V is equal to 39 by 40 meters. So, this we know very clearly is when we calculate it for a distance of 39 meters. Now, after 1 second, u will be equal to what? u was 39 meters and it is going at a speed of 5 meter per second. So after 1 second, what will be the value of u? So if it is coming towards us or going away from us, as it is coming towards us, that's been told, so it will reduce. So 39 will become 34, u will become minus 34. So if u is minus 34, then applying the same rules here, okay, you can calculate what is the value of v. V will be equal to, after 1 second, what will be the value of v? V is here again 1 by v is equal to 1 plus 1 by 34, which is 35 by 34, or we can say it is 34 by 35 meters. That is the value of v. So what is the change in v? That means v here is nothing but the image position. Image position has moved from 39 by 40 to 34 by 40. So change in image position, let's say velocity of the image actually equal to, okay, 39 by 40. So it was earlier 39 by 40, now it is 34 by 35. Okay. So 39 by 40 minus 34 by 35, or the other way around, final minus initial, doesn't matter, we want just the value. Okay. So this whole divided by 1 second, in 1 second, distance by time. So you compute this. So this will turn out to be a value which is 1 by 280, 1 by 280 meters per second. Okay, look at this. The object speed is 5 meter per second and image speed is so small, 1 by 280 meter per second. Okay. So similarly, if you actually calculate for 29 meters, so whole thing will actually just substitute 29 here, and then when you calculate, so for 29 meter when you calculate, you will get it as 1 by 150 meter per second. And for 19 meters, you will get it as 1 by 60 meter per second. And for 9 meters, you will get it as 1 by 10 meters per second. All these cases are much less than the 5 meters per second. Okay. However, when it is coming nearer and nearer, you can see that its speed is getting increased. 1 by 280 is smaller than 1 by 250 and smaller than 1 by 6. 1 by 10 is the highest speed when compared to all these 4. So that means that though the object is moving at a constant speed of 5 meters per second, image is moving with a variable speed of going from 1 by 280 to 1 by 2. That means image is getting accelerated. Object is actually going at constant velocity. Image is getting accelerated. The more it comes nearby, the more speed it takes. So you can calculate acceleration and all that. I will not go into too much deep into that. So, but this you get an idea. So you can actually kind of observe this when you sit inside the car. Okay, sit inside the car and look at the mirror. A bicycle approaching from behind looks very slow, but when it comes nearby, it really speeds up. Okay. Even when you are driving, even when you are going in the car, if you look at the mirror, and backside car when it is approaching, trying to overtake you, when it comes very near, it looks to pick up a lot of speed, though it may be coming at a constant speed. Okay. So that is basically because of this reason. Okay. So we got a fairly good understanding of I hope reflection. Okay. So I will not spend too much of time more on reflection now. So the next step that we are going to do is to take up refraction. Okay. So refraction is something that we have studied. Again, refraction has many different things. Refraction through from going from rarer medium to denser medium, denser to rarer medium, total internal reflection, all that is there, okay, and its applications. Then we get into curved surfaces, we have lenses and how to deal with them, then we have prisms. So, all these things we are going to study under the heading of refraction as our next step. Okay. Thank you.